binomial means two terms. Everybody listen, this only works for two terms. So if we're multiplying out two terms, because once again, binomial means two terms. X minus 1 is a binomial. If I have x squared plus x minus 1, that's three terms. That's not a binomial. Yes? No. So we're learning how to multiply out a binomial, but quicker than by hand. So look, if I asked you to do x minus 1 squared, you would multiply out, you would write it out as x minus 1 times x minus 1. You would double distribute, combine like terms. Doable. X minus 1 cubed, you would multiply these two together, combine like terms, then multiply in the third. Also doable. X minus 1 to the fourth. You'd multiply these two together, combine like terms, then multiply those two together. So still not bad, but anything after that, it starts to get tedious and hard. So if I asked you to multiply out x minus 1 to the 8, you would say no thanks, until you learn today's lesson. We're going to learn a quicker, faster, much more efficient way to multiplying out binomials. So don't write this down. Right here, all I'm showing you is some things to notice, some important things to notice. So focus here. A plus b to the first would multiply out to be a plus b. A plus b squared multiplies out to be this. A plus b cubed multiplies out to be this. A plus b to the fourth, that, a plus b to the fifth, and so on. I just am going to point out some key important features here. So everybody look. We're going to call throughout the entire lesson, if you ever see me say n, I'm talking the degree. So first of all, I want you to focus on the degree with me. So here's degree 1. How many terms do we have? 2. Degree 2 has 1, 2, 3 terms. Degree 3 has 1, 2, 3, 4 terms. Do you guys see a common theme here? So whatever the degree is, there will be how many terms? One more than that. So degree 4 has 1, 2, 3, 4, 5 terms. Degree 5 has 1, 2, 3, 4, 5, 6 terms. So let's test your abilities. Degree 20 has 21 terms. Okay, that's super important. Next thing to notice. The degrees in each term will always add up to be the same as the original degree. So let me show you what I mean. This is degree 1. In each term, it'll be degree 1. So look at this term. Degree 1, degree 1. Right here's degree 2. Notice degree 2. Right here, a 1 and a 1 adds up to be 2. So that's considered degree 2. So degree 2. Look, degree 3. Look, right here's a degree 3, a degree 3, a degree 3, and a degree 3. Why is this degree 3? 1 and 2 is 3. You guys see what I'm saying? Another thing. So once again, degree 4, 4, 4, 4, 4, and 4. So that's another thing to notice. Also important. The next thing to notice is let's just look at powers of, first of all, A. So what happens with powers of A, meaning the front, you're going to hear me call this the front thing. We have our front thing, and what is going to happen is it's going to start at the highest degree and count down. So right here we have, it's the highest degree is 1, so we have a to the first, and then we count down. This is a to the 0. Look, degree 2, you guys see how it starts at 2, then a to the first, then a to the 0 technically. Do you see how it starts at the highest degree and counts down? Look, 5, see it's degree 5, 5, 4, 3, 2, 1, and then technically a to the 0. So as your front thing starts from the highest degree and counts down, your back thing, the B, will do the opposite of that. So notice B will start at 0 and count up to the highest degree. So notice right here we have B to the 0, B to the first. Right here we have B to the 0, B to the first, B to the second. You guys see how it's just backwards? B to the 0, B to the first, B to the second, B to the third, ending with the highest degree. B to the 0, B to the first, B to the second, B to the third, B to the fourth. All right, and last thing to notice is the coefficients. So I'm not teaching you how to get these coefficients quite yet, but what I am having you notice is coefficients increase and decrease in the same pattern. I'm not showing you where the pattern comes from yet. Just notice. So look, coefficient 1, 3, 3, 1. You guys see how it goes up, then back down in the same pattern. 1, 4, 6, 4, 1. It goes up, then down in the back in the same pattern. 1, 5, 10, 10, 5, 1. Everybody good. Now where do the coefficients, where do they come from? So that's our next slide, and it's called Pascal's triangle. Still do not write this down. Do not write this down quite yet. I'm going to give you plenty of time to write this down. What's more important is noticing the things things I'm going to point out. So you really should be watching, okay? So Pascal is a mathematician, and what he did is he took all these different binomials, and by hand, he was multiplying and distributing them out and combining like terms. So as he did this with a lot and a lot and a lot of binomials, he noticed that this same pattern always occurs for all binomials, for the coefficients. Now coefficients mean number in front of the variable. So what we notice, still not writing down, is we have a triangle that's being created with diagonals of 1. That's kind of where we start. Still not writing down. So our top of our triangle is a 1 that has 1 term. So then the next line here would have 2 terms to create the triangle. So it'd be 1 and 1. The next row here would have a 1 on the diagonals, and then how are we getting the 2? We add the 2 numbers above it. 1 plus 1 is 2. Do you guys see how I got that? So then we put 1s on the diagonals, then look. 1 plus 2 is 3. 2 plus 1 is 3. 1's on the diagonal. Then look, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1's on the diagonal. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Everybody good with that? So how we can create. That continues on forever.
Please, Kyla Peterson and Abigail Peck to the front office.
Okay, awesome. I'll send them. Okay, so, sorry, I was still thinking about this. Next thing, sorry, I lost my train of thought. Now I'm trying to think of where I was at in my thought process. Okay, other thing I want you to notice is it starts with degree 0. A lot of people will call this degree 1, which would not make sense. Think about why. We just discovered degree 1 has 2 terms, doesn't it? Doesn't degree 2 have 3 terms? And so on. So if it's degree 0, there would be 1 term. So that makes sense. Degree 1 should have 2 terms. Degree 2 should have 1, 2, 3 terms. Degree 3 should have 1, 2, 3, 4 terms. Now one more thing to notice, this is really going to be helpful, I feel like, to go quick, is notice if it's degree 2, the first number you see after the 1's is a 2. Degree 3, the first number you see after the 1's is 3. Degree 4, 4. Degree 5, 5. Degree 6, 6. Does everybody see how that's kind of useful? Because then if I said degree 15, what would be, really quickly, if you had a Pascal's triangle, you'd look for the 15, right? And just go from there. That would be the row you use. Does that make sense, everyone? Okay, awesome. So now we're going to use this to actually start multiplying out and expanding a binomial. First example, a plus b to the 5th. If you want to write this one down, great. That would probably be good for you. This first one. I'll tell you the ones I don't think you need to write down. So this first one, probably write down for yourself, a plus b to the 5th. So the first thing you would do is say, what are the coefficients, the numbers in front of the variables? So we'd go to Pascal's triangle. Oh yeah, I'm going to give you a second. Create a Pascal's triangle. So ready, set, go. Don't look up here. You just saw how... Okay, like I said, you can always keep going with Pascal's triangle forever. So if you ever need to create more, you can. More rows. So let's just go. So we have a plus b to the 5th. The first thing we're going to do is write out our coefficients here. So we would have our degree 5. So look, 0, 1, 2, 3, 4. This is degree 5. Easier yet, we could have just located the 5, right? The first number after the 1. So then I'm going to write out 1, 5, 10, 10, 5, 1, giving myself a little space. Not really hugely important. Now understand, I'm going to show my work underneath here because it gets squishy otherwise. So now we're going to use that pattern that we saw happening in my first example where I said, notice these things. Didn't we notice that the front thing started with the highest degree and then counted down to 0? So we're going to start with our front thing, which is a. Start at the highest degree, a to the 5th, then count down. A to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and then a to the 0. Then we notice the back thing, including the sign, just so you know, is going to do opposite of that. So it's going to start at 0 and count up to the highest degree. So we have b to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, and then b to the 5th. Now before you continue, I would check a couple things because a lot of times you'll catch your errors right here. First of all, just a reminder, the degree should add up to be the same as the original degree. That's before you simplify. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, 5 plus 0 is 5. You guys see what I just checked real quick? And now all you do, you guys, is multiply straight down. Multiply straight down. 1 times a to the 5th times b to the 0. B to the 0 is 1, not 0. So that's 1. 1 times a to the 5th times 1 is a to the 5th. Okay, good. Let's move on to the next one. 5 times a to the 4th times b. So wouldn't that be 5a to the 4th b? Now it was positive. There was nothing to say it was negative, so we're going to put a plus sign. Now 10a cubed b squared. 10a cubed b squared. It was a positive, so plus. Then we have plus 10a squared b cubed. We're multiplying straight down. 5a b to the 4th. Multiplying straight down. 1 times 1. Any base to the 0 power is 1 times b to the 5th. So then we have plus b to the 5th. And we just multiply that out much quicker, much more efficient than actually doing it the long way. Especially when you get really good at this, you guys, it goes quick. Does that make sense, everyone? Pretty easy. Okay. The next example, I would prefer you did not write it down, instead just watched. Because there's only one more thing we have to take into consideration as of now, a negative. So just watch and see what happens with the negative. The next one I'll have you write down. So first of all, you'd say degree 4. So don't we locate the 4 on our Pascal's triangle after the 1. So we have 1, 4, 6, 4, 1. Okay. Now we take our front thing, which is a, start at the highest degree, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, a to the 0. Agreed? Now you take your back thing, including your negative. I'm going to need parentheses at this point because it's negative. So we have negative b to the 0, counting up, negative b to the 1st, counting up, negative b squared, negative b to the 3rd, and then negative b to the 4th. Before I move on, degree 4, shouldn't these all be 4? All is good here. Now I can finish this bad boy off. Now I've got to pay attention to the negative. So our negative is also raised to whatever power. Any base to the 0 power is 1. So we have 1 times a to the 4th times 1. A to the 4th. Now think about this. We have a negative raised to an odd degree, don't we? Won't that be negative? So we have negative 4 minus 4. And then we have an a cubed, don't we? And a b. Does everybody see how I pulled the negative in front? Now we have a negative to an even degree. Won't that be positive? So plus 6a squared b squared. Then we have a negative to an odd again. So won't it be negative again? Negative 4ab cubed. And then any base to the 0 power is 1. 1 times 1 is 1. And then we have negative b to the 4th will be positive b to the 4th. Now look, anytime you have a negative, it will always happen that it will bounce between a sign of positive, negative, positive, negative, positive. Why is that? Well, think about it. Isn't it going to bounce between even and odd degrees as we go through each term? So that's why. So anytime you have a negative, go back to your final answer, and if you see 2 negatives in a row, you made an error somewhere. Does that make sense, everyone? Okay, cool. If you see 2 positives in a row, you made an error. Okay, write this one down. Now this is as hard as it gets on, for the most part. Here's why. Not this one, this one. This one. Here's why. People really forget to take into consideration all the numbers. So you'll see what I mean by this. This is where people, if they don't practice, they usually make this error on the test. If they don't practice the homework and check their answers. You're not going to want to be this person. It is a waste to throw away this problem. It's easy. So first of all, you'd say, what are my coefficients from Pascal's triangle? So 1, 4, 6, 4, 1, right? Now in this one, our front thing is a 2. So we're going to put parentheses around it. We have a 2 raised to the highest degree, which is 4. Then we have 2 cubed. Then we have 2 to the 2nd, 2 to the 1st, 2 to the 0th power. 4, 3, 2, 1, 0. Now we've got to take our back thing, which is negative 3x, all of that in parentheses, and do that backwards. Negative 3x, 0, negative 3x to the 1st, negative 3x squared, negative 3x cubed, and then negative 3x to the 4th. Now before we simplify, check. It's degree 4. So 4, 4, 4, 4, and 4. So when you're calculating this, guys, you've got to take into consideration, look, for example, at this position, negative 3 is raised to the first power. X is also raised to the first. Right here, negative 3 is raised to the second power, and X is raised to the second power. Right here, negative 3 is raised to the third power. That's important. Here we go. Let's start calculating. Grab a calculator, because well, we might need it for some of it. Maybe some of it we won't. So look, isn't any base to the 0 power 1? So we have 1 times 2 to the 4th. That's 16 times 1. 16 is our first term. Okay, let's go to the next one. We have a 4, then times 2 cubed. Then we have times negative 3 to the first power. So you should get your calculator and be doing 4 times 2 cubed times negative 3 to the first. What is it? Negative 48, and then we have a x to the first, don't we, everyone? Okay, now right here we should have a 6 times a 4, or 2 squared, same thing, and then times negative 3 squared. You would need parentheses if you type it in to your calculator. What is it? That's 24 times 9. What? So this isn't 48, you're saying. 4 times 8 times negative 3 is what? So we need to change it to negative 96. Negative 96x to the first. Okay, good fix. So now this one, 6 times 2 squared times negative 3 squared. Okay, so plus 2, 16, and then don't we still have x squared? Now right here, don't be that person that goes 4 times 2 times negative 3. That's not what it is. It's 4 times 2 to the first times negative 3 cubed, which is negative 216. And then don't we still have an x cubed? Now we have 1 times 1, 2 to the 0 power is 1, and then times negative 3 to the 4th. Don't be that once again that person that says negative 3x to the 4th. Nope. That's 81, because that's 9 times 9, because that's 3 times 3 times 3 times 3, which is 9 times 9. So that's 81, and shouldn't it be positive? 81x to the 4th. Then check. Since there was a subtraction sign in the problem, my final answer should bounce between positive, negative, positive, negative, positive, negative. Yes, it does. All good there? You guys see what I'm saying when people go 6 times 2 squared times negative 3 and they don't square the 3? Okay, don't be that person. Okay, next one. I added this on after last hour because I felt like it was really going to help us with the last part of the lesson. So let's hurry and do this one real quick. So we have 1 over x minus 2y raised to the 5th degree. So our coefficients are 1, 5, 10, 10, 5, 1. So now we'll take our front thing, which is this, and don't we start at the highest degree? So we have 1 over x to the 5th, 1 over x to the 4th, and so on. Can I just not write 1 over x to the 0? Yes. Okay, because that's going to become 1, right? Okay. Now let's do the back thing, which is negative 2y. Right here is negative 2y to the 0, so that's why I'm not writing it. So then this is negative 2 and y to the first. You need parentheses, you guys. Negative 2y squared. Now check if it's degree 5, it should be 5, 5, 5, 5, 5, and 5. Okay, now guys, remember we're multiplying this out. So right here, isn't all this stuff raised to the power 1 to the 5th, x to the 5th?
Yes.
Okay, so we're looking at what's 1 to the 5th? 1. So we have 1 times 1. 1. Now, when we're multiplying straight across, won't the x to the 5th stay on bottom then? So we have 1 over x to the 5th. Okay, let's go to this one. Now, right here, once again, we have a 4th degree here. So we have 5 times 1 to the 4th. And then don't we also have times the negative 2 to the 1st? 5 times 1 times negative 2. So minus 10. Now we're multiplying straight across. So on bottom we have a x to the 4th, but what do we have on top? A y. Okay. Let's go to this one. We have a 10 times 1 to the 3rd power. And then don't we have times negative 2 squared? 10 times 1 times 4. Positive 40, right? So positive 40. Then we also have a y squared on top, don't we? Because remember, we're multiplying straight across. The way I've written this, sometimes it's hard for people to visualize. You guys see what I'm doing? I'm multiplying straight across. So then, on bottom, we would have an x cubed, wouldn't we? Okay, finishing this one off here. So what I want you guys to do is go finish. I did the first 3 terms. You guys do the last 3 terms, and I'll ask you in just a second. What'd you get for the pink arrow? This one. I've done this one now. Not 18. 80 y to the 4th over x. Anyone else get that? Okay. And then the final term. Yep. Perfect. Awesome. Okay, good job, guys. Yeah, now let's see, right here, couldn't we have technically, if we really so desired in our heart, if we really so desired, could we have gone like this and rewritten the problem as x to the negative 1 minus 2y to the 5th? Instead of dealing with fractions, couldn't we have dealt with negative exponents? That might have been easier. Should we try that on the next one and see if it's easier calculating? What do you guys think? Okay. All right, stay with me here. Okay, let's do this one real quick. I don't think you would need to write this one down. I think you should just watch this one. Okay, so do you guys think maybe we should use negative exponents instead? So we have 2x squared then plus x to the negative 1 raised to the 3rd power, correct? If I'm telling you, if I see any person on this exam cube that, and write that answer, oh man, I'm going to have a heyday. That's not going to happen. No? Okay. All right, so let's go. Coefficients, 1, 3, 3, 1. Okay, let's take our front thing. We have a 2x squared, and then what is it? Raised to the 3rd. We have 2x squared raised to the 2nd. 2x squared raised to the 1st, and then 2x squared raised to the 0. Okay, now we're going to take our back thing, which is x to the negative 1. So we have x to the negative 1 raised to the 0. I'm writing negative x. That's not the same thing. X to the negative 1. X to the negative 1 raised to the 1st. x to the negative 1 squared, x to the negative 1 cubed. Check first. 3, 3, 3, and 3. Okay, let's start simplifying. Calculator, because these are going to be some decently big numbers. Here's why. Okay, any base to the 0 power is 1. Let's just get rid of these 0 powers. Okay, let's calculate this first one. This one we won't need a calculator, but careful. We have a 1, and then we have 2 cubed. So we have 1 times 2 cubed, which is 8. So we have an 8 here. But now, what about this? Is it x squared? No, isn't it raise a power to a power and you multiply the powers? So that'll be x to the 6. Okay, let's move on to the next term. Now here we have a 3, we have a 2 squared, so isn't that 3 times 4? Isn't that the only number, 3 times 4? And then, so 3 times 4 is 12, so plus 12. And then we have an x to the 4th, don't we? And then we're timesing by what? X to the negative 1. Are we going to need to come back and simplify that in a second? When you multiply, you add. So we have right now 8x to the 6 plus 12x to the 3rd, right? When you multiply, you add. I think that was easier than dividing, but that's just me. Okay, let's go on to the next one here. 3 times 2 to the 1st is 6, so we have plus 6. And then we have an x to the 2nd. And then don't we have an x to the negative 2nd? When you multiply, you. So then we have plus 6, x to the 0, which is 1. So plus 6, don't we? And then here we have 1 times x to the negative 3. True? So 1 times x to the negative 3. So now what we would do is take our final answer and rewrite it, because you started with not negative exponents, you started with fractions. You would take your final answer real quick and just convert any negative exponents back to fractions. So what would our final answer be? 8x to the 6. Can you combine that with an x to the 3rd? No. Plus 12x cubed, true? Plus 6, and then plus 1 over x cubed. That would be your final answer. Okay. I don't know. It's up to you guys if you guys think that's easier or the division problem. I don't know which one, so that we know for future. I don't know. It's kind of 50-50, huh? Okay, awesome. Do you guys need to do one with a square root, or would you be okay? How would you do it then? You turn it into a 1/2 power, and then you would just go about it the same way. So you feel like you don't need it, or you do need it. You think you're good? Okay. Awesome. Okay, this is the last little piece of the lesson here. It's called the Binomial Theorem. NCR, start writing it down. So NCR is a formula that allows us to find the coefficients, the number in front of the variable, without using Pascal's triangle. It's the exact same thing as Pascal's triangle. It literally is. It calculates to be the same as Pascal's triangle. So you might be wondering, well, if I know Pascal's triangle, then why would I need to know the binomial theorem? And you will see why the binomial theorem is more useful than Pascal's triangle in certain cases. So, you'll see in a second. Okay, so right here, NCR, another way more likely to be written on your exam is like this. NCR, so this is like, it says N choose R. It's a probability thing. We're not going to get into it too much, but just N choose R. They'll write it more likely like this. It's like these big parentheses with N on top, R on bottom. Because N comes first here, N, R, so N is on top, R is on bottom. And then it calculates either of these things, if you see them, they calculate to be N factorial divided by R factorial times by N minus R factorial. And I'll remind you what a factorial is in just a second. So I just want you to notice, you would need to have this memorized for the exam, so just a reminder. So just look here, this isn't a reminder, I'm showing you something. So it's kind of easy, I feel like, to memorize because you'll do this factorial divided by this factorial times by this minus this factorial. So it's like, kind of goes in order, you know what I mean? This factorial divided by this factorial times by this minus this factorial. Okay, so right here we have 9 choose 4. So that would look like this. The formula would, oh yeah, one more thing to note, 0 factorial is 1. A factorial is actually just a man-made mathematical symbol. Like, it doesn't actually mean anything. It's a symbol symbol given to do the following. So let's write in what we have. 9 factorial on top divided by 4 factorial times by, now isn't the formula saying to take the 9 minus the 4? Look, 9 minus 4, 9 minus 4. So what, I'm just going to write 5 factorial. Does everybody see where I got that? I just plugged it into my formula right there. Okay, so let me show you what a factorial means. Factorial means start at 9 and multiply all the way down to 1. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what factorial means. So on bottom we have a 4 factorial, which would be 4 times 3 times 2 times 1. Then we're timesing that by 5 factorial. 5 times 4 times 3 times 2 times 1. Now what I want you to notice, and this is important to see, because you're going to see me do it from here on out in the future, look at the 5 factorial. 5 factorial. Won't that divide out? Yes. So how you're going to see me write it from now on is when I get to this point, I say, what's the largest factorial on bottom? 5 factorial. So I would go like this from now on. 9 times 8 times 7 times 6 times 5 factorial. Why? Because there's no need to keep writing that out. Do you see how I have a 5 factorial on bottom? You guys see why I stopped at 5 factorial instead of continuing? Then it divides out, and then I say I have then 4 times 3 times 2. It's the same thing. And then 1 won't matter, right? Times by 1. So that's why you're going to never see me really write the 1s in very often. Now look how easy from here you can just start simplifying. Yes, you could just type that in, but look. Do as much by hand as possible. It's just quick. Isn't 3 times 2 6? 6 and 6 divide out then. Then doesn't 8 and 4 divide out? So then that's a 2. So you have 9 times 2 times 7. So 18 times 7. So 126, and then it was divided by 1, so we don't need to write that. So 9 choose 4 calculates to be 126. So you'll see where we use this in just a second. Right now we're learning how to do the formula. So let's do 6 choose 3. So how would we write it? 6 factorial divided by 6 factorial divided by 3 factorial times by 6 minus 3 factorial. Wasn't that the, so that'd be another 3 factorial, wouldn't it? 6 minus 3. So how should I write the top? 6 times 5 times 4 times 3 factorial. I'm not going to keep going because don't I have a 3 factorial on bottom? And then I also have 3 times 2 times 1 technically from the other 3 factorial. So my 3 factorials divide out. Then look right here. 3 times 2 is 6. 6 and 6 divide out. So what do I have left? 5 times 4 is 20. 20 divided by 1 is 20. Okay. Now I'll show you where we're going to use this. That's the binomial theorem. That is the theorem, NCR. So like I said, this allows us to find the exact same thing Pascal's triangle gives us. So write this down for yourself, NCR. So N is going to be the degree you're at, and R is the position it is sitting in. You'll see what I mean when I kind of give you this example. Now it does start at 0 and count up to the degree. So the position starts at 0. There's a position 0. Then there's position 1, position 2, and so on. So NCR. So right here, do you guys see how I've written out Pascal's triangle? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. No, you're not seeing. Look, there's Pascal's triangle. 1, 1's on the diagonal. 1, 1 plus 1 is 2. You guys see what? I just have Pascal's triangle right here. 1, 3, 3, 1. Now, like I said, this formula gives us the exact same thing Pascal's triangle gives us. You'll see why it's useful in a second. Okay, so right here is degree 0. So notice 0, that's right here. N, I told you, was the degree. So it's degree 0. Let's continue our thought process on degree for a second. This is degree 1, isn't it? So look, 1, 1. You guys see how no matter what the degree stays? Degree 2. So look, degree 2, degree 2, degree 2. The degree's on top. This is degree 3. 3, 3, 3, 3. The degree is always on top, everybody. Now, the R part is the little bit trickier part. It's the position it sits in, like on the term. Now, it starts at 0. So, for example, 0 would be the only option here since there's one term. So right here, there's 2 terms. We start at 0 and we count up. 0 and then 1. Now notice it's always going to end on like the same as the degree on top, and then number on bottom will line up to be the same. So look right here. Starts at position. This is the first term, second term, third term. So we start at 0, 1, 2. Do you guys see how 2 and 2 end up? Okay, now what do we notice then if this is true? What is this going to be compared? Look, here's the first term, second term, third term. If this is 0, if this is our first term, this is 0. If this is our second term, this is 1. If this is our third term, this is 2. So what can we say about our R? R is always Is R always 0? Okay, but good try. Well, yes. Here's the first term. I know you got this, guys. I'm not coming up with some big complicated thing here. What? Yes. Okay, what I'm going for, you guys, is, this is what I'm going for. Ready? I'm going to blow your mind. This is always 1 less than the term it's on. True? If this is the first term, this will be 1 less than that. If this is the second term, this will be 1 less than that. If this is the third term, this will be 1 less than that, which makes sense if we start at 0, doesn't it? If you're starting at 0, won't the next term always be 1 less than the term above? There's not a 0th term. Does that make sense, everyone? So right here, this is the first term. Do you guys see how it's 0 here? This is the second term. This is a 1. This is the third term. It's a 2. It's always 1 less than the term it's on. This is the fourth term, and it's a 3. Does that make sense, everyone? Because it starts at 0 and counts up. That's really important to notice. All good? Okay. So, guys, this 0 choose 0 calculates to be 1. 1 choose 0 calculates to be 1. 1 choose 1 calculates to be 1. 2 choose 0 calculates to be 1. 2 choose 1 calculates to be 2. 2 choose 2 calculates to be 1. Do you guys see how it's just getting me the same thing as Pascal's triangle? Okay. So let's see why this would be useful. If you're not asked to expand the entire thing, this is a lot of times when it's useful. You'll see another time it's even more useful. So this says find the third term in the expansion of 2x minus 3, and I'm going to add in the instructions because that's what I think they might do on the test, using binomial theorem. I can't spell theorem right now. Oh well, okay. So find the third term in the expansion of the binomial, using the binomial theorem. So I'm going to just draw myself a teeny tiny bit of a visual for the first couple examples. We're not doing the first term, we're not doing the second term, we are doing the third term in expansion. Does everybody see? Now if it's degree 7, how many terms total is there? 8. Okay, good. Now I only care about the third term. Do you guys see? So that's just kind of my visual here. So now let's go figure out what our binomial theorem is going to be at. If we were using Pascal's triangle, wouldn't we now first go find what this is on Pascal's triangle? We're not using Pascal's triangle though. We're using the binomial theorem. So isn't the degree 7? That goes up here always. Now if this is 3, what should this be? 2, because it started with 7 choose 0, 7 choose 1. That would put us at 7 choose 2. Everybody good? Now it wants the entire third term. So before we calculate that, let's keep going. So what do we do next when we were doing the whole thing? We took our front thing and we started with the highest degree. So wouldn't this have been 2x to the 7th? So this would have been 2x to the 6th. So this would have been 2x to the 5th. Okay, good. Now remember, we would take our back thing, which is -3, and we would start at 0. -3 to the 0, -3 to the first. So this must be -3 to the second. Now we didn't even have to work backwards with that one because remember, since this was 5, didn't we know that this had to be 2 so that it added up to be 7? Okay, so just pointing out. Okay, so now let's calculate this. The first thing we need to calculate is our coefficient, the binomial theorem. So that's 7 factorial divided by 2 factorial times by 7 minus 2, which is 5 factorial. So the math would tell us to do 7 times 6 times 5 factorial. That would divide out. So we have on bottom a 2 factorial and we have a 5 factorial. Don't my 5 factorials divide out? So then I have 7 times 6 divided by 2 times 1. So now don't I have 6 and 2 divide out to become a 3? So that would be, so I have a 21 is the coefficient, which makes sense. If you look at your Pascal's triangle, you would see that the third term in, go to degree 7, go to the one that would be degree 7, everybody. Look 3 terms in. Do you guys see the coefficient is 21? Okay. So then from there, we have to multiply by a 2 to the 5th, don't we? And then we also have a times by a 9, and then times by x to the 5th. Wouldn't it make sense to put all the numbers in front? So tell me what the final answer here is. I don't need you to have you say thousands or anything, just for quickness sake. 2, 6, 5, 4, whatever. 6048. So x to the 5th. Did anyone else get that? Okay, cool. So we're done. So now some of you might be thinking, still Pascal's triangle would have been easier to use. Yeah, I agree with you. But this next example will show you why it would not be in this next one. So let's read this next one. It says, find the term that contains x to the 5th in 2x plus y to the 20th power. Now look, 20th degree. 20th degree. Would you want to do Pascal's triangle out to 20 degrees? Heck freaking no. That would take you so long you would run out of time on the exam. So this is a good example of when you'd say, I have to use the binomial theorem. So now this says, what is the term that's going to contain an x to the 5th in this expansion? So just kind of to give yourself a visual, if it's degree 20, we're going to have how many terms? 21. Now I don't want to have to draw out 21 places, so I'm just going to do a few and then do some dot, dot, dots. So here's our first term, second term, third term, fourth term, dot, 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 and then like let's do a couple at the end. So like maybe 17, 18, 19, 20, 21. Here's our 21st term. Does everybody see what I'm saying? All right, now let's figure out which term in here is going to contain our x to the 5th. Well, right here, our front thing is 2x. So won't this be 2x to the 20th? Everyone, if we were going to expand this whole thing. Well, then let's go back to the very end here, because 5 is more on the bottom end. So wouldn't this have been 2x to the 0? Then this would have been 2x to the first, 2x squared, 2x cubed, 2x fourth. So then it would be this one right here, right? This is 2x to the 5th. So what term is that? 21st, 20th, 19, 18, 17, 16. So now we know we're finding the 16th term. Does everybody see how that took some thought process? Okay, now we'll finish. It says, what is the term? It didn't say what. It says find the actual term. So we need to actually calculate. So now this is no different than saying find the 16th term in the expansion of this. So remember, the first thing we do is find the NCR thing. What's the degree? 20, and we're not doing 20 choose 16. That's what so many people do. It's 20 choose 15 because it started at 0, remember? So we have 20 choose 15, and then we have a 2x to the 5th, which we know. Now, we don't want to have to even think about it. We know it should add up to be 20. So we'll take our back, think y, and what would the degree have to be? 15, because doesn't those two need to add up to be 20, everybody? Does that make sense? Remember, this degree will add up to be these two things before you simplify. All right, let's simplify this. So everybody go. You calculate 20 choose 15. I just want to know what 20 choose 15 is for my video. So everybody practice that. I'm not going to do the math. You see if you can do 20 choose 15. Perfect. Were you able to get that? won't we take and times that by 2 to the 5th? Because look, 2 to the 5th. Okay, so let's hurry and do that, and then we're almost done. So you said 4, 9, 6, 1, 2, 8, and then we have an x to the 5th, y to the 15th. There's our answer. That is correct. Very, very good. Yeah. Woohoo. That is how I feel like they're going to word one. You know, they're going to make sure you use the binomial theorem. Okay, this is my final example, and it is the deepest, probably thinking one a little bit. So it just took us a minute, first hour. We did it wrong to start with, and so we're not going to do it wrong this hour because we are good. We're doing much better. Okay, so my question is, do you guys personally look at this problem? We have a fraction. Did you like negative exponents better, or do you like to do division? I heard most people say negative. Do you agree? So then we have this, x squared plus x to the negative 1 raised to the 10th. Agreed? Now it says find the coefficient of the term. It just wants the number in front of the variable that has a term x to the 8th. Now here's the problem. The front and back both contain x. Do you guys see? So we've got to actually do some simplification here. So if it's 8, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. Agreed? Alright, so let's take our front thing. Our front thing here, well, let's go quick. Isn't it x squared? So this will be x squared to the x squared to the 10, isn't it? X squared to the 10, x squared, 9, x squared, 8, x squared, 7, x squared, 6, x squared, 5, x squared, 4, x squared, 3, x squared. Did I miss something? 10, 9, 8, 7, 6, 5, 4, 3, 2. I didn't write out enough blue spaces, did I? That's why. Which is weird. Just x to the 8th, though. That doesn't necessarily mean the 8th term, though, everybody, right? Watch. It's because things simplify. That's why we've got to be careful. So then right here we have x squared to the first and then x squared to the 0. I just feel like there's not really an easier way to show this by like doing it all out. Okay, what's our back thing? X to the negative 1, isn't it? X to the negative 1. So isn't this? Okay, let's think here. So we have x to the negative 1 to the 0. This will be x to the negative 1 to the first. True? X to the negative 1 squared. X to the negative 1 cubed. X to the negative 1 to the 4th. X to the negative 1 fifth. X to the negative 1 sixth. X to the negative 1 7. X to the negative 1 8. X to the negative 1 9. X to the negative 1 10. Okay, now think about this. This is all multiplication, keep in mind. This is x to the 20th. It's not the first term. Isn't this 18? And then we have plus negative 1, because this is a times sign, everybody. When you multiply, you add. Does everybody see? That's 18 plus negative 1. That's not it. This is 16 plus negative 2. You guys see why I'm saying that? 14 plus negative 3. We're trying to get to 8. 12 plus negative 4. Isn't that 8? So we know now it's this term. So now you can say 1, 2, 3, 4, fifth term. You'd say, I'm finding the fifth term. So now it said find the coefficient of the term that has x to the 8th, which we know is the fifth term. So what would be our NCR? That's how we find the coefficient. 10 is the degree, which is 10, and then it's not choose 5, but choose 4. Okay, so we have 10 factorial divided by 4 factorial, and then times by 6 factorial. 10 times 9 times 8 times 7 times 6 factorial, which will divide out with 6 factorial on bottom. So then we have 4 times 3 times 2 times 1, don't we? So now what I'm going to do is go like this. 4 and 2 are 8. That divides out with 8. 3 and 9 divide out 3. 10 times 3 times 7.
So why does that always
there wasn't a 10 on bottom?
Like on top, because 10 goes all the way to 1. So you go 10 out of 7, 6 factorial,
Yeah, so then at 6 factorial it started to divide out.
I'm saying 4, 3, 2, 1 also gets all divided out.
No, because then you're double dipping. There's a 4, 3, 2 and this isn't there as well.
Oh, yeah.
You can't double dip. Does that make sense? Okay, what is it? 210. Now, do I have to worry about any of the other things? Because remember, the coefficient isn't necessarily just 210, right? But isn't this a 1 and isn't this a 1? So that won't change because it's all 1. So 210 would be my answer. I can't tell if you guys completely are lost or get it. Because it said find the coefficient of the term that has x to the 8. So we only needed that one term, which we figured out was the 5th term. Does that make sense? All right, start practicing. That's how it's not overwhelming, is when you practice.
Is tomorrow the hour lunch?
Yeah.
What time does that start? I can interrupt you and then start one.
I need to look up the schedule myself.